Good morning and happy Tuesday 10 at 10. I am your host, Richard Charpentier. And every week we receive questions sent from bakers and answered by yours truly, certified master baker and owner of Baking Innovation. And today I put a really nice July wheat field. That's the way it should look like. And just as a way to to show bakers that wheat, it comes from the field. So let's get started with our questions. So our first question is someone asking whether or not parabens can be used in breads and cake, and is this better than sorbate and calcium? So parabens have been used in a lot in cosmetics and fruits, and as a way to prevent molds. And why is this being used less today than before? It could be economical. If you look online, which I have, there's a lot of petition for people to say, it's not as quote unquote clean. So remove. But having worked 36 years in the bakery world and manufacturing industrial bakeries, parabens is never one ingredient that I've come in contact in my field. And I worked in Europe, I worked in the Caribbean and the US, so it's not common. I'm not saying it's a bad ingredient, but again, from the standpoint of product development, it's going to require work on your part to do the testing and to see how it's changing your cake and whether you're getting your money's worth. And probably, the other options of the sodium propionate or calcium propionate could, be more economical. So that's what parabens was, moved out of the sideline. So, but great question. Now, for our next question, it's regarding baking powder. So it's a question regarding using aluminum with tartaric acid in baking powder. Does it not give good results like when using pyrophosphate? For instance, making baking powder with pyrophosphate helps cakes rise better and make it fluffy. So now we're talking about chemical leavening. And your question is whether or not, to use sodium aluminum phosphate in combination with tartaric acid, which is cream of tartar, will, works well. So sodium aluminum is a very versatile leavening acid. And if you want to learn more about leavening acids, I recommend going to Bakerpedia. There's a great section, a great read on leavening acids and their usage and neutralizing value. But in the case of sodium aluminum, it's a slow reacting acid. So when you're using tartaric, it's a super fast reacting acid. So technically, if you're using that with cream of tartar, you're making your double acting baking powder, which they all made with a monocalcium phosphate, which is the fast reacting, reacts right away, and followed by sodium acid pyrophosphate of different grades, and that will continue as the cake is baking based on the size and shape. So regarding whether or not what works better and fluffier, this is again going back to trial and error, because your formulation is also what dictates the size of your cake, is what dictates. If you bake a small cake that's going to bake in 10 minutes versus a large sheet cake that's going to bake in 40 minutes, your rate of reaction, referring to the chemical leavening we're talking about, will be different. You don't want to get all up front. The fastest, because all of the leavening system we're using, it's an acid-base reaction, and similar to all of what happens when you take baking soda and you put vinegar on top of it, is going to start foaming and exploding. So that's the principle of an acid-base reaction. The difference is with the sodium aluminum or the sodium acid pyrophosphate, the reaction is going to be delayed. And by delaying, it's not going to react right away. So that's why you have the fast reacting, you have the slow reacting, you have the very slow reacting. So they'll react differently. And that's why picking the right leavening acid for your product is super important versus just going with a generic baking powder, because they're great, but baking powder you buy, double acting, it's similar to buying all-purpose flour. So can you make all-purpose, can you use all-purpose flour to make bagels and everything else? No, everybody's choosing. So same thing with baking powder. So I hope I answered your question, but great question. So now moving on to our next question. It's on Alveograph. What would be considered a significant difference between two Alveograph readings when doing comparison between flours? So the Alveograph is an analytical tool similar to the Ferritograph to measure quality and strength of different flour. It's a great quality control tool if you can have one for all the incoming loads of flour you're getting, to ensure you're getting the same type of flour. And in the case of the Alveograph, if you get different readings, the way it works is you will look at a curve. You have a P curve, you have your length, your L curve, or the W. So the P curve, it's the pressure reached when the dough will burst. So that's when it inject air and you'll see, and all of a sudden it breaks. So that's your P curve. Your W is the curve under the area under the curve, and it shows the strength. The longer it is, the more strength it is. And the L, the length at which the curve will go, it shows the extensibility. So any changes that you see within your readings or within the data of your Alveograph reads will indicate changes. When I used to run a lot of the analytical data for AIB, we'll do triplicates. So, and you look at your standard deviation and you monitor whether or not it's significant enough of a difference to call it a difference. And that's what I recommend. If you just get one read and you get your P is going to be you have one P that is that long and one P that is half. Yes, you have different flour. And then you need to make certain adjustment, in order to get consistent product, same as you would do, in a regular day-to-day operation for a bakery. But great question. And again, on Alveograph and Ferritograph, I recommend to go to the Bakerpedia page, where you'll find a lot of great free information to help you and guide you through with, if you have more questions. So, and now for our last question, it's on water absorption. Does water absorption affect the water activity in the finished product? Is there a relationship between water absorption and water activity? So yes, a flour can absorb more water based on the way it was milled, based on the variety, based on the amount of ash, based on the amount of bran, etc., will affect your absorption. And to your question, does water absorption affect water activity? Yes, it will do it, because the water will be held by the new flour. It has the ability to absorb more, and therefore the more water you put in, the higher the water activity, because in most cases in flour, and I'm sure people could say I've seen it different, but in most cases it's not bound water. There's holding water and binding the water. Binding the water is what affects water activity and will lower it. Right now you put more, but your water activity will go higher. So therefore you have to watch for more mold growth, and again, I don't know your water activity results, but as you have to add more water, you will have more water in your product. It can be changed through the bake profile. As you increase 2 to 3% of moisture within your product, you might need to adjust your bake profile in order to adjust the side walls and to ensure the breads do not collapse. So again, cause and effect, there's always little things that need to be done for the bakers in order to adjust on a daily basis to different things. But that was an excellent question. That's a big topic. Water activity and water absorption are two different things. And yes, they do affect each other, but they're not correlated, direct correlation. So, all right, that's it. So thank you very much for listening to Tuesday 10 at 10. I will see you next week and have a great rest of your day. Thank you.